All right, welcome back to part 2, graphs. Now today we're going to deal with a parabola, all right? So the first thing that we're going to deal with is the parent graph of the parabola, and its equation is y is equals to x squared. Now this parabola is a little bit different from the previous graph, which was the linear function. How do we know that it's different? Because here where there is x, now we are being told that the exponent is 2. Whereas when we're dealing with the linear function, we were told that the parent graph was y is equals to x, which means this was to the power 1. So the moment we see this to the power 2, remember on the linear graph, we said that here we had what? 1 intercept, 1 X-intercept. That's the linear graph. However, because we are having y is equals to x squared, it now means that this parabola, it has got 2 X-intercepts, right? But we are not going to start with what? Intercepts. What are we going to start with? We're now going to start with getting to know the values to say that what kind of graph do we get if we're given y is equals to x squared. So here now, remember, f of x is the same as saying y, right? Now, so now here we're being told that when our x is negative 2, right? What is y? Y is 4. But how come we got this positive 4? I want you to remember one thing. This x squared, when you are dealing with the parabola, if you are doing the calculation would be like this. Function of when our x is negative 2, then I place the negative 2 here, is equal to. Now, before I write this negative 2, I must open a bracket, and then I place the negative 2. I close the bracket, then the squared is outside. Now, when I do this, the answer that I get is a positive. If I do not put this bracket, the answer that I was going to get would be a negative, and negative 4 would be a wrong answer. So when you're dealing with this parabola, the x values, your domain, please open the bracket, close the bracket, and then square them. I hope I'm clear. Now, when we go to x, when our function is at negative 1, our y is 1. When our function is at 0, our y is 0. When our function is a positive 1, our y is a positive 1. And when our function is positive 2, our y is positive 4. And then I took the pleasure to what? To draw the graph, to show this, what do you call it? The values on a graph. Remember what I said from the first video. I said to you, functions are represented in 4 different ways. Number 1, it could be words. Number 2, it could be a graph. Number 3, it could be the table method. And number 4, it could be coordinates. So in this particular instance, we are using what? The combination of the table method and the graph. So now, when our x was negative 2, our y is 4. And I came here, this is our x, which is negative 2, our y is 4, positive 4. When our x is negative 1, our y is positive 1. When our x is negative 1, there is our y, which is positive 1. When our x is positive 1, our y is positive 1. And when our x is positive 2, our y is positive 4. So this is the graph of function of x. Then I name it here. So its name is function of x. Do not forget to name your graph. Do not forget to name your graph, right? So this is our graph. This is the parent graph. Now, what are we going to observe? We are now going to check the reflection of function of x is equals to x squared. What do we call the reflection of function of x? We call it g of x. You can see that I used a different marker. I used a red marker. Now, let's observe. When our x is a negative 2, what is our y? Our y is negative 4. Let's observe, how was this calculation made? It was made like this. They said g of, then we're at negative 2, so you say negative 2 is equal to negative, open bracket, negative 2 like this, then squared. Now you continue to say g of negative 2 is equal to, the negative you still rewrite it. Why? Because you have to start with the brackets. This negative 2 squared, it gives you positive 4. So I've got a positive 4 here. Now you say therefore g of negative 2 is equals to positive multiplied by negative, you get a negative. So we've got a negative 4 here, right? So that's how I got this negative 4. Just because here it's a reflection and we're having a negative, it doesn't mean that you must stop using the brackets. So when we're at negative 1, our y is negative 1, and when we're at 0, x is 0, our y is 0, positive 1, negative 1, 2, and negative 4. And here is the graph of the what? The reflection, right? So when our x is negative 2, our y is negative 4. When our x is negative 1, our y is negative 1. When our x is 0, our y is also 0. When our x is 1, our y is negative 1. When our x is 2, our y is negative 2. You can see, now you can see for yourself graphically that this is a reflection. This is the original, the parent graph, and this is the what? This is the reflection. Now, remember one thing which happens with the reflection. The reflection, we must know where is it happening. So the reflection is happening here about the x-axis, meaning to say that here this is what we call our mirror line. The x-axis is our mirror line. And when you reflect on the x-axis, what happens? Your x values, they don't change. What just changes is the y values. Observe here, if you check your negative 2 here, it didn't change the negative 2 here. We're still at the negative 2. But we're on top with the positive 4. Now when we reflected it, it's here at the bottom, which is now the inverse. The opposite of positive 4 is a negative 4. So what changes are your y values when something is reflecting on the x-axis. Observe what changed. Here on the x values, nothing changed, but the y was positive 1. Now the y is negative 1. The y here was a positive 1. The y is now negative 1. The y here was positive 4. It's now negative 4. So what changes is the y values when your parabola is being reflected on the x-axis. So I hope everybody can see and understand the difference between the parent graph and the reflection of the parent graph. Now, on the next video, we are going to be working on what? We're going to be continuing with the parabolic function, but we're now going to be investigating what we call the effects of A. What do I mean? This equation now, we are now adding. Now we say y is equal to ax squared. So our investigation, it's going to be about what? This parameter A, to say that how does it affect the normal graph of y is equals to x squared? How does it change it? Effect, we are simply talking about what is the change that is brought about by this letter A. So do join me on the next video. Thank you.